It's a little bit misleading. Today we're just going to deal with sequences. And tomorrow we'll do series. So definitions of sequences. Sequences are just your number patterns. If I tell you list out all your even numbers and you go 2, 4, 6, 8, and onwards forever, that's a sequence. So any number pattern you come up with, that's a sequence. We have two types of sequences. Well, here let's do this first. Okay, let's do that. Sorry, I wrote that a little small. This is, make that bigger, like a magnifying glass there. That's a n minus 1, a n plus 1. Okay, each one of these things is called a term. Let me change colors here. When we do terms of a sequence, your book uses the letter A to represent any member or any term of your sequence. And then we always use subscripts. So a sequence might, so there's the sequence of even numbers. Now, this is considered an infinite sequence.
Is it because it can go on and on?
Yep. And then we can also have finite sequences. And finite sequence ends after a predetermined length. So, we may say that our sequence ends after 20 terms. And that's just a finite sequence. So, a finite sequence, we may start with A1, A2, A3, and goes on. We have A19, and then A20, and then it ends. So that's a finite sequence. Okay, so that's just some definitions. You guys have had enough tests for me to know that I'm not going to come out and ask you, what is the definition of a finite sequence?
Can you actually do that this time? That sounds pretty easy.
No. Okay. So, some things you might actually be asked to do. Write out the first five terms of this sequence. That's really simple. All you're doing is you're literally taking the number 1 and plugging it into that equation. So, A1 would be negative 1 to the 1 power over 2 times 1 minus 1. So negative 1 to the 1 power would be negative 1 over 2 times 1 is 2 minus 1 is 1. So the first term is negative 1. That's all it takes to find a term. So to find the second term, I plug in 2. So negative 1 squared over 2 times 2 minus 1. So negative 2 squared is 1. 2 times 2 is 4, minus 1 is 3. So second term is 1/3. And after a little while, you can probably do them in your head. Third term, negative 1 cubed is going to be negative 1. 2 times 3 is 6, minus 1 is 5. So my third term is going to be negative 1/5. Fourth term is going to be what? Can you see the pattern yet? 1 over 7. What's the fifth term? Negative 1/9. There's your first 5 terms. If you don't see the pattern yet, you just keep plugging in numbers. That's all it takes to find first 5 terms. You'll be given the formula. You plug in the numbers. Okay, so if I want to find the 20th term, what do I do? Plug in 20. So to find the 20th term, I simply plug in 20. So 60 minus 2 is 58. That's too easy, right? It's not fun yet. No, that's not fun at all.
Just make a test just off of that.
We have to have some fun. And it's not fun until you can think about it. So,
No, that's not fun.
let's write some sequences. So find the nth term, which means what they want you to do. Yeah, find the rule. So what is a sub n? So now there is no, I could give you some rules to find this, but there is no simple, quick, and easy way of doing this because it's going to change every time. You actually have to use your head and try to find a pattern and figure something out. Some things that will help you is line up your terms with their place in the sequence. So, first term is 1, second term is 3, third term is 5, fourth term is 7. Yeah. Some other things that might help is finding differences between things. If it's linear, what you'll notice is there will always be the same difference. That pen is not working at all. There it goes. There will always be the same difference in between those if it's linear. So notice I'm always adding 2 to each of these. If you always add the same number, that means you have to have something like that. That gets you close, right? 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. That gets me close to each of these numbers each time. What else do I have to do? Minus 1.
Could you also have n plus 2 or something like that?
Nope, won't work. Only one equation for each pattern.
Okay.
Well, that's a little bit of a lie, but there's some places where you can have close to the same equation, but for the most part, only one equation for each one. What I'm talking about, sometimes with the negative ones, your power can change because you just really need the power to be even or odd. So, you know, someone could have n plus 1, the next person could have n minus 1. It wouldn't matter. It would still be the same thing. Okay, so for this one, if you try to do the same thing with this one, it won't work because it's not linear. But one thing to notice is, notice that the sign changes every single time. Anytime the sign changes, that means you're going to have a negative 1 to a power. Well, the first term is positive, which means I need the power to be something like either n plus 1 or n minus 1. Because I need the first power to be even. Well, if I just use n, that would be odd. So I need to add 1 to it so it becomes even. But anytime you alternate signs, you'll have something like that. Okay, so how do I turn 1 into 2, 2 into 5, 3 into 10, 4 into 17? Yeah. As quickly as it's growing, what you're going to have is you're going to have the perfect squares.
So Mr. Collette, why'd you put n plus 1?
Because if I just put n, this would be negative. Because I need an even power up here to get this to be positive.
Oh.
As quickly as it's growing, what you need is you need the squared. Notice that 2 squared is 4, 3 squared is 9, 4 squared is 16. So all of these are really close to the squared terms. In fact, they're just one more than the squared term.
Wait, but how would that work for a negative 17?
Because I do the negative after I add the 1.
Gotcha.
So what I did is I take 4 squared, which is 16, plus 1, which is 17. Then I take it times the negative. Okay. Yeah. What the n plus 1 does is it keeps our power on track with the value. So we want the even ones to be negative. Well, if I just use n, that would make the even ones positive. So the n plus 1 makes the even n odd. I could also use minus 1. All we want to do is we want to change, anytime the n is even, we want to make it odd. Anytime it's odd, we want to make it even. Now, this is pretty much like anyone that you have to do is going to be something like this. That's why I did these two examples. You'll either have something linear or something where they're going to have you do a square. You may have something with a fraction. The fraction will either have, at the bottom of the fraction, will be something that's linear or something involving a square. That's why, again, that's why I did these two examples. I was very specific about what I did. Okay. Two more things. Recursive. What recursive means is you use your previous answer to get your next term. So, gave you an example here. If we do maybe the first 5 of them again, should be enough to kind of show you. Now, if they're going to do something that's recursive, they always have to give you the first term. But if I give you the first term, A1 is 3. So if I want to find A2, A2 means I take 2 times, okay, this would be, n right now is 2, so this would be A sub 2 minus 1 plus 1. Well, 2 minus 1 is 1, so this is the same thing as A1. A1 is 3. So A sub 2 is 7. So to find A sub 3, I have to plug A sub 2 in. To find A sub 4, I have to plug A sub 3 in. And A sub 5, same thing. So A sub 5 would be 2 times 31 plus 1, so it'd be 63. So the problem with recursive definitions is if I ask you to find A sub 20, you have to know A sub 19. And in order to know A sub 19, you have to know A sub 18.
Wait, so why do you need the previous answer though?
Because that's how I defined it.
Oh.
In order to know the next one, you have to know the previous one. That's what recursive means. It's like, and you guys should already know a really well-known one, which is the Fibonacci sequence. Right? The Fibonacci sequence, A1 and A2 are both 1. Oh, that's Josh. Yeah. Yeah, that's fine. The Fibonacci sequence, your first 2 terms are both 1. What's your third term? 2. What's your fourth term? Fifth term? Your sixth one is 8. 13. So, Fibonacci sequence is defined like this. So your Fibonacci sequence, you take, to get any term, you add together the 2 previous terms. So your Fibonacci sequence is a sequence that's recursive. So to know any term, you have to know the 2 previous terms. Okay, one more topic. We good with this one? All right, factorials. Factorials are fun. I love factorials.
You're math teacher. You love anything math.
No, you get to use an exclamation point. It's English.
So exciting.
Okay, so a factorial, this means factorial. So I'm going to use number 6 to show you what factorial does. What you do with a factorial is any number that you take the factorial of, you take that number and you multiply it by all the numbers less than it, all the way down to the number 1. You never go to 0, because if you multiply it by 0, then the answer is just 0. So 4 factorial would be 4 times 3 times 2 times 1. So 4 factorial is 24.
Do you really need to multiply the times 1? Like exactly?
No, but that's how it's defined.
No?
Well, I mean, if you take it times 1, it's just 1. But I'm just saying, that's the definition of it. I think I said it's just 1. It's not just 1, it's itself. But you understand what I meant, not what I said. Okay, so we can use factorials and sequences. If we take this and do the first 5 terms, a sub 1 will be negative 1 to the 1 power over 1 factorial. So that would be negative 1. A sub 2 be negative 1 squared over 2 factorial, which would be 1/2. Because I just take 2 times 1. A sub 3 would be negative 1 cubed over 3 factorial. 3 factorial is 3 times 2 times 1. So it'd be negative 1/6. A sub 4 would be negative 1 to the 4th power over 4 factorial, which we just calculated to be 24. So it'd be 1/24. A sub 5 would be negative 1 to the 5th over 5 factorial, which is 5 times 4 factorial, which is 5 times 24. So 5 times 24 is 120. I wanted to do this on purpose because this will help you with the next problems. I was being tricky and intentional, I promise. Okay, so then you're going to be asked to simplify some factorials. Simplifying factorials is fun. I actually enjoy doing this.
Where are the whiteboards?
The whiteboards? I have no clue.
Oh, you don't anymore?
That's Miss Lindstrom's thing.
Oh,
Okay, so I want to simplify this. Some calculators have factorial buttons, some of them don't. Factorials get big enough that if you go very high with your factorial, your calculator will run out of space and it won't even try to calculate it. And I don't remember, I did this one time. I think my calculator back in high school got up to maybe 16 factorial before it like just stopped with me. But there's not even any reason to do this. So walk through this with me real quick. So 10 is 10 times 9 And it keeps going, but I'll just stop there and I'm going to write that as 9 factorial. The reason for that is because on the bottom I have a 9 factorial, and those two things will cancel out. Okay, so 10 factorial is 10 times 9 times 8 times blah, 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 right? Okay, if I take from the 9 and scrunch all those back up, that's 9 factorial. Because 9 factorial is just 9 times 8 times 7 times all those, right? So if I just take the 10 off the top, I have 9 in all those numbers, which is 9 factorial. Here, let me do it this way. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so 10 factorial, I wrote that out. 9 factorial, I wrote that out, right? Now, oh, I forgot a 3 here. That's why it's not cooperating. So if I pull the 10 out, everything else cancels out. Because the 10 factorial only has one extra number from the 9 factorial, and that's the 10. Now, I'm going to simplify this a little bit more. Okay, we just said, and Manny said this nicely, the 1 doesn't really matter, right? Okay, 10 is also what? 10 is what two numbers multiplied together? 5 times 2. So the 10 is 5 times 2.
So then it'll be
1 over 6 times 4 times 3. So there's my answer. So all you're doing with these is you're doing a whole bunch of cancellation. So with this one, I could rewrite this as, well, the 6 factorial could be written like this, correct? So that I can cancel out the 5. The 4 factorial could be written like this. So I could cancel out the 3. So then my answer is 1 over 24. Yep.
On the bottom, where did the 5 come from?
I have 6 factorial, right?
Yes.
Okay, so I take the 6 out, which leaves 5 factorial.
Okay.
That's where the 5 came from. Okay, so how about 10? Nope.
So the numbers that cancel out go to the number of the top.
You can cancel them out anywhere. It just happened to be that I was canceling out numbers from the top. What? Because 5 times 2 times 1 equals what? So they canceled with the 10 on the top. So everything canceled out except for the 6, the 4, and the 3. So multiply those together, you get 72. So it's just happened that every time everything cancels out to be the top. What if I gave you something like this? 12 factorial over 10 factorial times 2 factorial. What is that going to be? Answer is going to be 66.
It's when you take it out, it's 12 and 11, but then you take 2 out of 12 and it's 6.
So 12 I can break down like that. Why did I stop at the 10? I stopped at the 10 because I want that 10 to cancel out with this 10 on the bottom. Now on the bottom I have that 2 factorial, which is 2 times 1. Well, this 2 and the 1 I can take and cancel out with the 12. What's 12 divided by 2? 6. Okay, so all I'm left with is 6 and 11, which make 6. So it just happened that every time I had a 1 on top. I didn't think it through whenever I was making examples. I didn't mean for you guys to see that as a pattern. Okay, this one, if I take n plus 1 and I start writing this out as a pattern, what's the next thing below n plus 1? N, because each time we subtract 1, right? So this would be n plus 1 times n times n minus 1 times n minus 2 times n minus 3 times n minus 4.
So it's n factorial.
But I'm just going to stop there because I have an n factorial on the bottom.
How do you know it's and your times exclamation point when you separate them on the top?
Same way I know whenever I take a 10 out of 10 factorial that what I'm left with is 9 factorial.
So then how did you figure, so why was the plus 1 removed?
Whenever I have this, and I take this out, how do I get that next number?
It's because it's the lower power or something.
Okay, it's the next number is 9, right?
Yes.
I get that by subtracting 1 from the 10.
Mm-hmm.
Okay. If I subtract 1 from this, what is left?
N.
N.
Makes sense.
And then I stopped there because that matched what was on the bottom. I could have kept going because, if I have my next number, I subtract 1 again. If I subtract 1 again from this, that would be n minus 1. So, if there was an n minus 1 on the bottom, maybe I could have stopped there. I can stop wherever I want to. The point is, each time you spread that out, you subtract 1 each time. It's just with the ends, you don't know how far you need to go because they don't give you a number. You just go as far as you need to go. Okay, so homework.
Yay.
I know, isn't that fun?
Yes. Thank you, Mr. Black.
Yeah, I don't think the homework's fun, but whatever, makes you happy.
Yay. You can really excited.
Okay, I tried to be choosy and picky about these so that it's not, a lot of problems.